And finally, let's look at our third objective, convert equations between rectangular and polar forms. In future sections, we may want to be able to graph polar equations. And so to prepare for that, we're now going to look at two common techniques to derive polar equations from rectangular equations. One of those methods is to square both sides of an equation. And another one of those techniques is to multiply both sides of the equation by r. Now let me show you what I'm talking about here. And I should let you know that the process for doing this is not exact. It's a little bit like when we were confirming identities. In other words, you just start with maybe trying one of these top two techniques and then manipulating your equation by just doing the things that you're able to do. And what I've written over here to the right is just a reminder of some of the things that we discovered on the previous slides. For example, we know that x is equal to r cosine theta, we know that y is equal to r sine of theta, and we know that x squared plus y squared is equal to r squared. So example 6 says, transform the polar equation r equals cosine theta into a rectangular equation. So r equals cosine theta. We want to get rid of the r, we want to get rid of the theta, and we want a rectangular equation that involves only x's and y's. So what can I do to this thing? Let me try maybe doing the step 2. Step 2 says to multiply both sides of the equation by r. So if I take r equal to cosine theta and I multiply the left by r, then I have to multiply the right by r. Now why do you suppose I wanted to do that? Well, on the right I get r cosine theta, and r cosine theta looks familiar to me. In fact, if you look over to the right, you'll see that r cosine theta is equal to x. That's nice. And r times r is r squared, and what is r squared equal to? Well, again, over on the right, we saw that r squared is equal to x squared plus y squared. Now, here's the way I feel about it. Once you've gotten rid of the r and the theta and gotten x's and y's, my opinion is that you're done. On a test or a quiz, I would accept it at this point. You could continue to manipulate a little bit, depending on what the instructions are. You might want to move all your variables over to one side, and you would write x to the second minus x plus y squared equals 0. But you don't have to do anything else. You're not being asked to solve this equation. You're just being asked to transfer a polar equation into a rectangular equation. So we're done with this one. So let's look at an example. Transform the following polar equations into rectangular equations. The first one is r equals 5. So believe it or not, if you had your graphing device set to polar instead of to rectangular, r equals 5 would actually graph something. It would be the graph of something that has a radius of 5 but no angle specified. When no angle is specified, that means you can use anything. So imagine the points 5 comma pi over 6, 5 comma pi over 4, 5 comma 5 pi over 3, 5 comma 3 pi over 2. In other words, all of those angle measures with a radius of 5 connected. Now what would the picture look like? So you might have a guess about that. Let's see if your guess is correct by transforming this polar equation into a rectangular equation. Now I know a lot of things about r, but you've got to keep your focus here. I'm trying to get rid of the r and get an x and a y. So to me, this third equation seems the most appropriate because it doesn't have a theta in it. X squared plus y squared equals r squared. So what I'm going to do is I'm going to turn this r into r squared by squaring it. And if I square the left, then I square the right. And so I end up with r to the second equals 25. Well, r to the second is x to the second plus y to the second equals 25. Now, you may or may not know this from previous classes, but x squared plus y squared equals 25 is the equation of a circle. If that doesn't feel familiar to you, that's okay, because we're going to talk about this in later sections. But I think it makes sense based off of what I originally said. In a polar system, if you had radiuses of 5, so let me go out 1, 2, 3, 4, 5, and you had that for every single angle that was on that polar graph, and you connect all of those points, you would see that indeed you have yourself a circle. The second example, r equals 4 times the sine of theta. Let's see, I could square both sides, or I could multiply both sides by r. I think I'm going to multiply both sides by r simply because I do have a theta involved this time, and so it would be really nice maybe to see an r sine of theta or an r cosine of theta. So if I multiply both sides by r, I'm going to get r to the second. Let me go ahead and just write this. R times r, and then 4 r. That's 4 times r times the sine of theta. So I get r squared equals 4r sine of theta. So let's see, r squared we know is x to the second plus y to the second. And we know that r sine of theta is y. So that whole thing can become a y. And so I get equals 4y. Now, like I've said, instructions in your homework may be to simplify this more or to write it in a different form. Maybe you want to move the 4y over to the left, so maybe you would have x to the second plus y to the second minus 4y equals 0. But for me on a test or a quiz, I'm going to accept either one of the answers as long as the r and the theta are gone and the x and the y are there. Example 8. Now we have a rectangular equation and we want to change that into a polar equation. So these I think we know a little bit more about. What does y equals 3 look like? If you were to put this into your calculator, y equals 3, I believe, is a horizontal line. So let's see what we've got here. Y, and remember, what I want is to get rid of x's and y's, and I want to get r's and thetas. What does y equal? Well, we know from our formulas in the gray box that y is equal to r sine of theta. So this entire left-hand side can be written as r sine of theta. And we can say that that is equal to 3. Now, that doesn't feel like very much, but we've gotten rid of the y and we've gotten the r sine, excuse me, we've gotten the r and the theta, so I'm done. Y squared equals 3x. What can I do to that? Well, y is r sine of theta, so let me just put that in there, but now of course I have to square it. And x is equal to r cosine of theta. And let me see, have I done what I wanted to do? I got rid of the x and the y, and I got r's and thetas. So yes, we could simplify that more, but I'm good with it in that form. So that's it.